Okay, what's up? First things first. We're just going to go over some basic radian degree stuff. So first of all, I'm going to just draw a circle. Now, if I cut that circle in half, actually we'll cut it in half again because hey, this is the x and y plane. So there's x, there's y. Now, everything starts from here. Everything starts from on the x-axis positive. Now, as we go up, this goes around here. We get up to 90 degrees. We go around, we get to 180. We come all the way full circle, we get to 360. Now, 360 degrees in radians is called, oh, that's a 3, is called 2 pi. That's where we start. 2 pi is 360. Pi is 180. So remember that pi is equal to 180. And then we can cut the rest of the circle up. So what's half of that? Well, if this thing to there is pi, then that means that this thing to here is pi over 2. So it's half of it, right? We just cut it in half. Now we can cut this thing in quarters, and that's your 45. So this is 90 degrees right there. Pi by 2 is 90. If we cut that again, there's 1/4 is 45 degrees. There's 3/4, which is 135 degrees. And then remember that always 180 degrees is pi. Okay, but I don't want to cut it into 45s. Let's cut it into 6 pieces with sound effects. Okay, so 6 pieces. Now, when I cut something into 6, that means that this is a sixth of it. So this is pi by 6. Now, this up here is 2 pi by 6, because you count up. That's 1, that's 2. It's 2 pi by 6. We reduce that, though. 2 pi by 6 is equal to pi by 3. So, pi by 3. So, remember, pi by 3, 60 degrees. Pi by 6, 30 degrees. Because divided by 6 is smaller than divided by 3. Because when you divide by a bigger number, it makes it smaller. So this is 30 degrees, this is 60 degrees, 90 degrees. By the time we get over here, I now have 1 2/3 there. Or 1, 2, 3, 4 sixths. 4 sixths reduced to 2 pi by 3, and then add one more. I'm now at 5 sixths, which doesn't reduce, so 5 pi by 6. And then over here one more. This is 6 pi by 6, which reduces to pi. Okay, now as you keep going around, remember that you just keep adding sixths on here and then reduce. So add another sixth. You get, okay, so we had 5, 6, this is 7 sixths. 8 sixths, we reduce it to 4 pi by 3. This is 9 sixths, which reduces to 3 pi by 2. And what do you know? Because it's a 90 degree, it's got the same, well, it's got the same acute angle, but I'll get to that later. 3 pi by 2 is 90 degrees. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 of them is 5 pi by 3s. 11 of them can't be reduced, so 11 pi by 6, and then 12 pi by 6 is 2 pi's. I'm just going to scribble that out there. Okay, so you need to know this thing. You also need to know the one that is for 45 degrees, which you can also make up just on the spot. Cut that up, remembering that this is pi, then if I cut this, it's pi by 2. Then if I cut it into my 45s, it gives me pi by 4, because I cut it into fourths. So this is 2 pi by 4, reduces to a half, 2 over 4. This is 3 pi by 4, can't reduce. 4 pi by 4 is just pi. 5 pi by 4. 6 pi by 4 reduces to 3 pi over 2. Hey, same thing here and here. Good, otherwise you screwed it up. And here is 7 pi by 4. And here again is 8 pi by 4, or 2 pi. So you need to know these two things. They are very important. You need to know how to create them and what they look like. Now, while I'm here, I'm going to go just quickly talk about something called related acute. It's very important. What is the related acute angle, which means the closest angle to the x-axis? So what's the related acute of 5 pi by 6? Well, what's the angle that's in here? That's in this 5 pi by 6, closest to the x-axis, well, it's pi by 6. The cool thing about radians is all your related acutes, like let's say I have 7 pi by 4, guess what the related acute angle is? Pi by 4. Sweet. Let's do 13 pi by 6. Related acute, pi by 6. And just so I don't leave out pi by 3, 4 pi by 3, as you can see, where is that? Up here, nope, down here. So 4 pi by 3, it's in quadrant 1, 2, 3, and it is a pi by 3. It's related acute angle. Related acute angles are very important with the next thing that I'm going to do. So remember that to get a related acute, we just, well, we take that number off of the numerator and just leave it like that. Bam. That's how related acutes work. So whenever you get one of these, you know the related acute is that. That will tell you the exact answer, and then you use the cast rule, which you better know by now, or you's in trouble. I will talk about cast and exacts in the next video. That's all for now.